Here's a quick set of slides on pressure and the 4 ways to describe 4 measurable qualities of a gas, and we'll roll this into using these 4 conversions. So we've talked about in Boyle's law and Charles' law that the 4 measurable parts of a gas are volume, temperature, number of moles, and pressure. And we have this equation PV equals nRT. We're actually going to go through this later. That's called the ideal gas law. So we'll cover that in a few more slides later. So when we look at pressure, we want to understand that pressure is a force per unit area. Force is measured in newtons, and the force is caused by gas molecules hitting the wall with their collision. So you saw that when we were looking at the computer diagrams with both Charles and Boyle's law. The air around us exerts a pressure on us, which is why when we're in airplanes and stuff like that, our ears pop. So the pressure is changing, so our inner pressure systems in our ears are also changing to help with equalizing that and stabilizing that pressure. So if we went into space, what would happen to our eyeballs? So you got to think about it. We're talking about atmospheric pressure, and because in space there is no atmospheric pressure, our eyeballs would explode because the pressure pushing out on the atmosphere from our eyes would have nothing to stop it because there's no atmospheric pressure in space. So the most pressure, where's the most pressure? Is it sea level, ocean bottom, or mountain top? So when you think about it, pressure, atmospheric pressure, okay, we generally think of sea level being the most atmospheric pressure, but in this example, the ocean bottom is actually below sea level. So our ocean bottom would have the most atmospheric pressure, our sea level would have the second most, and then the mountaintop would have the least pressure forcing upon it because it's at a higher elevation. So just measuring atmospheric pressure, if we see here, this is a barometer. So this is a vacuum, so this is just the atmospheric pressure forcing down on the vacuum here, and it's forcing down on this liquid. So the more pressure forcing down, the more this liquid is going to move up this barometer, and we can measure that pressure right here in, millimeters or inches of mercury. So Hg is mercury. We don't use mercury for thermometers anymore because they might break and that's hazardous, but that's what was used to be used. So right here, just an example of pressure varying based on the sea level, or based on the altitude, I should say. So pressure at sea level is 1 atmosphere, or 760 millimeters of mercury, and pressure at a mountaintop would be less because there's less atmospheric pressure forcing down on it. So the lower the elevation is going to equal higher pressure from the atmosphere. So again, just a picture of a barometer here. The air is pushing down, and note that the vacuum has nothing inside it. And again, if we have more air pushing down on this, it's going to make H increase, and we measure that value of H to figure out what our pressure is. So how we measure a gas that's not necessarily atmospheric pressure is using a manometer, and we like to call it a manometer because that's kind of what the word looks like here. And so there's 2 equations, so you do need to write these down on your notes because these are very small, so they're sometimes hard to read. So in this example here, we've got that the pressure of the gas, okay, if the pressure of the gas here looks like it's like the atmosphere is forcing the liquid in this towards the gas, we can say that the pressure of the gas is less than the atmospheric pressure. So we would take the atmospheric pressure, so you need to know the outside pressure, subtracting the height of H here to figure out what our pressure is on the inside. And vice versa, if it looks like the pressure of the gas here is forcing that liquid out, okay, so then if that's happening, then we know that our pressure of the gas is greater than the atmospheric pressure, so we would take the atmospheric pressure and add the height of H. And we'll go through these again, but this is just a good simple equation here to help us remember how to calculate an unknown pressure of a gas in a manometer. Standard temperature and pressure, so we will use this all the time, especially in the gas unit, and we're going to start our conversion slides with this as well. So you need to know standard temperature and pressure. You need to know that at standard temperature and pressure it equals 1 atmosphere at 0 degrees Celsius at sea level, and the pressure is, again, 1 atmosphere, or 760 millimeters of mercury, or 760 torr. So we're going to start this next slide set with our conversions and understanding that we need to be able to know what STP is, so we'll abbreviate it STP, and then we'll need to be able to convert from different units to be able to calculate with STP. Okay, so there's your note set for pressure and the 4 measurable qualities of a gas.